Hi, thank you. So my name is Shuyi Chen, and this is my colleague Rong. And so we are from the Uber's stream processing platform team. Today in this talk, we are going to share some of our experience in running Apache Flink in production. First, some quick fact about Uber. So we are on more than 600 cities across 64 countries and on 6 continents. Our mission is to create opportunity through movement. Next is the outline of the talk. First, I'm going to cover an overview of our stream processing platform at Uber. And then I'll talk about how we scale our job management. And then Rong is going to cover how we do cluster management and also how we secure our stream processing jobs in production. And in the end, we'll conclude. So first, let's talk about an overview of our stream processing platform at Uber. So our stream processing platform is built on top of Apache Flink and Apache Calci. Currently, in production, we have about more than 3 trillion real-time messages per day in Kafka. And we have about 1,500 Apache Flink jobs across multiple data centers. And in each data centers, we have multiple clusters with tier SLAs. Currently, for the tier 1, tier 0 clusters, we offered 4-line availability SLA. And our current stream processing platform offers 2 solutions for our users at Uber, Athenax and Flink as a service. So next, I'm going to talk a little bit about the 2 solutions. Athenax is built on top of Apache Flink. It's our self-service, SQL-based stream processing platform. So users of Athenax can use a web UI that is managed by the platform to compose their SQL logic of the stream processing job and deploy and run the job in production. So it's a fully self-service experience. Once the job is deployed and run in production, the job will be managed by the platform. And also the infrastructure side, like Yang HDFS, will be also managed by the platform. Complementary to Athenax, we also have another solution called Flink as a service, which actually offer native Flink job development for our users, which cannot express their stream processing logic in SQL. So user can use Java and Scala to compose the stream processing job very close to what you'll be doing in the open source Apache Flink. And the framework, the platform basically provides minimum wrappers and libraries to integrate well for your Apache Flink jobs with Uber's internal systems, such as logging and metric system. Once the job is deployed in production for Flink as a service, it will be managed by the owning team. And the infrastructure side will be managed by the platform, such as Yang and HDFS, so that we let the user actually focus on develop their stream processing logic and the productionization of the job without worrying about the infrastructure. Currently in production, we have about 70% jobs running as Athenax, and about 30% of the job running on top of the Flink as a service framework. Next, I'm going to talk about how we scale our job management. So what are some of the challenges around job management of streaming jobs in Uber? So first, we have about 1,500 long-running critical jobs in production. With this number, imagine actually like 1 or 2 jobs might fail every 1 day or so. So this put actually a load on our on-call and platform team. And also, in Uber, we have multiple data centers and also multiple deployment environments within each data centers. And this multiplies the complexity of the job management by actually 2 dimensions. And not to mention that we only have a small team of less than 10 people that manage all the jobs. So to tackle these challenges of scaling our job management, the first things we do is we build a service that manages all the SQL job deployment in production. We call it the Athenax Job Service. So the Athenax Job Service serves as a deployment abstraction layer that is built on top of the multiple data center and multiple environment in Uber. Environment can include sandbox, staging, production, tier 0, tier 1, and tier 2. With the Athenax Job Service, we centralize all the job management for the SQL jobs. And also, we hide the infrastructure configuration details from the users. So the user don't need to worry about like when we move from an environment to a different environment and between data centers. So this is making it easy for us actually to migrate jobs between environment and migrate jobs between data centers without the user's knowledge. And also making it easy to actually upgrade Flink version from one to another. So the next challenge we want to tackle is how to we scale our operation, how to handle the job failures. So with 1,500 jobs running in production, long-running jobs, job failure is normal and also is inevitable. So to scale our production operation, we build a service called Athenax Watchdog Service to do all the automatic job monitoring and recovery for us. And in production, we find that actually the Watchdog Service is able to auto-recover 99% of the failures due to transient system failures or machine failures. And also with the Watchdog Service, we centralize all the job monitoring and recovery in one service for all the Athenax SQL jobs. This has enabled us to actually do smart things, for example, to prioritize job recovery based on service tier of the jobs, doing a catastrophic failure when a large number of jobs fails in production. And also this enables us to do batch job recovery, doing custom maintenance and failures. Currently, we are working on extending the Athenax Job Service and also the Watchdog Service for our Flink as a service-based jobs as well. So our target goal is actually to build a unified job service for all the Apache Flink jobs running in Uber, and will be served as a central registry for all the Flink jobs, and also a deployment abstraction layer for the multiple environment, data centers, and also different cluster resource scheduler in Uber. And also we want to build a unified watchdog service for all Flink jobs. This will enable us to do smart things to, for example, prioritize the job recovery based on the service tiers on a platform level for all the Apache Flink jobs. Next, Rong is going to cover cluster management and security.
Thanks, Shuyi. So as Shuyi mentioned, we have started our Athena projects about 2.5 years ago. By the time, we don't have too much of the applications running in production, so cluster management really wasn't too much of an issue. But once we scale to thousands of jobs running on the data centers and the clusters, this becomes really much of a challenge for us. So our main challenges is really threefold: cluster maintenance, catastrophic cluster failures, as well as DC turn-up and decommissions. So let's look at the first. So we run Apache Flink on Yarn and mostly communicating to and from Kafka. So Yarn configuration was actually a pretty nice framework for us to run cluster management, and also Flink has a very nice integration with Yarn as well. But once we onboard more and more Flink as a service users who use Java and Scala code, we found out that they have a lot of creative ways on how to use Flink. So we constantly need to tune the parameters on how we configure Yarn. Sometimes we even need to use version upgrades on Yarn as well. And these would cause container failures. Imagine you take down the entire cluster batch by batch and doing maintenance. Right, so what we do here, we enable the node manager soft downtime. So this actually is a trade-off on our side because on the one hand, all your containers no longer tied to the node manager thread. You can basically take down the thread, do some maintenance, and bring it back up again in a short time. And none of your job will lost because Flink actually has a pretty nice job manager to task manager communication channel. But on the other side, it inevitably have a risk to impose orphan and zombie containers. So what we do here is we impose some really extensive metrics monitoring to ensure that once these zombies gets detected, it automatically gets killed so that no rogue traffic will go into the production real-time traffic. Another aspect of this is, as you can imagine, once we roll out all of these changes, there is going to be situations where you run into a problematic deployment and you need to roll back. So this is where the tiered cluster the setup that Shuyi just mentioned comes into play. we basically separate the analytics and business critical use cases into two different physical clusters so that you don't have to worry about one problematic deployment affects everything. Once it was fully deployed and tested in the analytic cluster, we just move it to a more critical tier, to 0 or maybe 1 clusters. Another aspect of this is Kafka. So Kafka also goes into cluster maintenance modes pretty frequently. So we want to ensure that whenever a temporary broker was actually downtime, we don't want our Flink job to just start bouncing all over the places in the Yarn cluster because it cannot connect to Kafka. So we set a pretty aggressive consumer retry timeout, so that policy, if you will, to basically deal with these broker rolling restarts. Another aspect of this is cluster failures. We are talking about some catastrophic failure scenarios, not just like one node going down. For example, on one case, we have both of our resource managers going down. As some of you might already know that this is actually the default setting for Yarn, so that you have one backup and one active node. And to prevent this from happening, we actually provision more than just 2 resource managers. I think we have 3 to 5, depending on the tier of the cluster that is supporting the service for. The other aspect of this is the networking. So once we have the scenario that the Yarn IP cache invalidation was happening way too quickly, that when a DNS server cluster failure happened, before our networking engineer can find out the issue, the entire Yarn cluster was lost from the resource manager because it cannot even detect where the nodes are. So that we're rolling out some pretty aggressive, longer internet address TTL settings as well to ensure that our networking engineer have more time to debug and resolve the issue. And this is also largely possible because most of our clusters are running on premise and the IP address doesn't really change that much. The other aspect of this is HFS. So we use HFS as our state store, but it's shared with all the other data stacks, so we cannot provide the level of SLA we require, as you can imagine, with 4 nines availabilities on one cluster. So what we do is we basically take 2 HFS clusters together with a federation so that we have automatic synchronization between state checkpoints between these 2 clusters. So whenever one's HFS goes down, we automatically restart from the other. So this is actually may have a problem of like the state checkpoint might not be up to date, but at least we won't get into a situation that you have to restart from fresh, or even the worst is you cannot even restart at all. DC turn-up and decommission is also pretty unique scenarios on our side, especially you have to do it so frequently. As the Uber's business grow, we also need to maintain a high cost efficiency and performance for our data centers. So we're consistently reevaluating on-premise versus cloud providers, or even the location of the data centers. So we basically decided to standardize the entire procedure by automatically batch migrating jobs from one data center to another. This is including how to synchronize the job metadata stores, using HFS federation, as I just talked about, to synchronize the states between 2 data centers. And eventually, all the deployment, verification, and queue will all happen in single click of a button. And also, as Shuyi mentioned before, Watchdog was actually in the background to keep making sure that all of the jobs gets verified, doesn't get queue or fail again because there's like so many batch of jobs all starting all together at the same time. So here are a bunch of current and future works that we are collaborating with the Flink community as well to improve the stability of Yarn, including some of the very highly discussed problems in the mailing list as well, such as the infinite Yarn resource allocation and exceeding physical memory allocations. Looking forward really with the Flink community to resolve all these issues and make it better. So next comes security. So as you can imagine, security is taken pretty seriously in Uber. So the challenges on our side on the data stack is a little bit different because Kerberos is mostly used in our data stack as the main security scheme, including Apache Hadoop, Yarn, HDFS, et cetera, But our corporate side was actually using a proprietary PKI service for all of the microservice layers. So this poses a problem for our customers to manage 2 different data security scheme. So we decided to centralize all the credential management for ourselves so that our customer don't have to worry about it. So let's look at how we convert the corporate PKI to Kerberos. As Shuyi just mentioned, we have a centralized job management and centralized deployment management system. This makes the perfect place for us to make the conversion. So basically, we set up these conversion mappings between the service account LDAP groups towards the Kerberos credentials within this deployment service. And this also have another benefit is to limit the number of distribution of the Kerberos credentials so that our users don't have to worry about where the key tab is, where the KDC is, et cetera, et cetera. The other aspect of this is impersonation. So as you can imagine, we have a centralized deployment service. We need to deploy the job on users' behalf. There's a lot of benefit about this because as long as the job was running on the user's account, it makes the tracking much, much easier. So what we did here is we evaluate a bunch of possibilities, but eventually we choose to use the Yarn's native impersonation and delegation token approach to basically deploy all of the jobs so that there's no key tab involved during the deployment. But as you can imagine, all the Flink jobs are long running, so we need to ensure that the job can run beyond the maximum delegation token delay, which is 7 days. So we actually need to install the key tab somewhere. So this is actually a trade-off that we evaluated as well. Unlike the traditional Flink default use cases where you basically use a distributed file system to upload securely your key tab files to the file system and let Yarn basically localize it during the container localization phase, we actually pre-install all of these Kerberos key tabs on each Yarn node. There are a bunch of trade-offs. First of all, we actually taken out one instability or dependency during the deployment process. As you can imagine, we wanted to support 4 nines availabilities. The less dependency we have during this deployment process, the better. The other way to look at this is if we use the default settings, then key tab files will be in the deployment service, will be in the distributed file system, also be in Yarn. So there are many places that you need to basically keep track on where are these very sensitive information were. So another trade-off for the reason why we decided to do this is because right now all the key tabs are only installed in Yarn and provide security by the Linux ACL, so that we don't have to worry about where these key tabs are. So here are some of the current and future works, including some of the security improvement proposals that we've done in the community, as well as 2 of the pretty much implemented PRs and JIRAs that we talk about. One of them including how to create a service provider pattern to basically dynamically load any security suite that you want to use, either proprietary, third party, or whatever, so that it's flexible enough to deal with the security systems that you have to run in your environment. This also extends to the connector as well. For example, in here, I haven't talked about how to make Kerberos back to corporate PKI. For example, some of our MySQL databases, et cetera, they are sitting in the other side of the PKI world. So we have to worry about that as well. So this makes it much flexible to handle these type of scenarios. So in short, we gave an overview of the streaming processing platform in Uber, including 2 of our major platforms. And we built our Athenax Job Service and Watchdog services. They are pretty much scaled to our business right now, and we want to extend it to fully 100% support all the Flink jobs. And we also share some of our experience in cluster management, especially the maintenance and catastrophic failure tackling, and DC tune-up and decommissions. And we also share the experience on how we secure our Flink applications. There are a bunch of current and future works also going on in collaboration with the community, so I'm really looking forward to getting all of these improvement in and make sure our share of experience can be applied to everyone else in the company. Thanks.
So we have time for 1 or 2 questions. Please raise your hand and we'll bring you a microphone.
Hey, I had a question about the Watchdog service. So it sounds like the Watchdog service was used to help restart the Flink jobs when they fail. That's right. Did you use any of Flink's built-in job restart logic at all, or did you just let the jobs fail if they crashed once?
Do you want to talk about?
I can talk. Yeah. So actually, Watchdog is kind of like a last safeguard when we enable all of the Flink's internal native failure recovery mechanism. But sometimes those mechanisms just don't have enough information on what exactly is the job. For example, there's a schema evolution happening. We need to recompile the entire C code and then resubmit the job, and the actual job binary gets changed in that time. So these are type of scenarios that it's like the last mile we want to went through so that we can cover 99% of the time that the failure happened, it will automatically recover so that we don't have to, wake up at night to deal with these type of things.
Yeah.
It is.
So schema evolution was kind of introduced not far back. So and you have quite a lot of critical jobs. So I was wondering how do you handle incompatible schemas and kind of loading state after upgrades and even like Flink upgrades from one version to another?
So currently, in terms of schema, so we use Apache Arrow. So actually, in Uber, we build another library on top of Apache Arrow. So it's a Apache Arrow guarantee. I mean, the schema is backward compatible. So that's basically the assumption that we rely on. So in terms of state, right now, when we migrate jobs, I mean, like from different environment and between different data centers. So we are right now using the HDFS federation to copy the state over. And of course, in the case where, for example, for SQL jobs, where the newer version of the SQL might get compiled into a different DAG. So in this case, I mean, we currently don't have a good solution for that yet. So yeah, that's a good question.
Okay, I think time's up. We have like 6 minutes left till the next session start. Thanks a lot.
Thank you.
Thank you.